Okay, so this may or may not be a public video. I've already recorded this once and I messed up, so I'm going to try to keep this quicker than the 20-minute video this was before. But this is a base64 converter in Minecraft. To set it up, you have to do function base64 setup. This just sets up some storage spaces. If you're using this in a map or something, just put it in the load function because you have to run it every time the world starts up. Next is just inputting some values. So let's go ahead and just generate a base64 string. Let's just do a base one that I was using this to test on. We will just do a base64 encode. We'll copy that value, and then I'll show you how to write to the system. Let's go ahead and do data modify storage base64 in string set value, and then we will put this into an array, and then in this array we will separate the values by a comma. We have to put quotes around the 8 or else it'll get confused, and then we just do that. So now if we do data get storage base64 in, as you can see we have agvsbg8h. that corresponds to hello. To run this, you do function base64 convert. That will run approximately 197 commands per character in the array. I'm making a more optimized version that does a lot less commands, but for now that's what it does. I like how I don't want to call it elegant, but I like how elegant how I'm doing it right now is. It's a lot more complicated, but I enjoyed the process more than the more optimized version, and I'll talk about how that works shortly. That will output, we're just moving on, that'll output a string of bytes into base64 out. We have an array of bytes here. These correspond to the ASCII characters in bytes. So we have 104, 101, 108, 108, 111, and 33. So this is HELLO explanation point. So that is our output bytes. It just converts your base64 string that you input into a set of bytes that correspond to the ASCII characters that you inputted. This is the base64 standard, basically. Now this system also does something else. So if we do function, let's put in some data. Let's actually, a little bit of background first. If you do data get yourself here at s, as you can see right here, we have a base64 value on this skull under the textures value. This is a base64 value. Basically, if I go ahead and input this into the system, so if we do function and just use one of my data functions, I'll use my player skull specifically, and then if I run function convert here, it'll run a bunch of commands and stuff, about 92,000. As I said, it's about 197 per character, and my player head has 468 characters. I have this all written down. I was doing calculations on how many commands per character. It's about 197. I already said that. Now, something else that this can do is it can do some parsing to figure out if that player has a cape. So if I do data get storage cape check main, as you can see, there are bytes. There's a bunch of information here in the cape byte section. This is the URL for the Realms Mapmaker cape. Now, if I go ahead and input data for someone that does not have a cape, and then run both of these again, as you can see, there's less commands being run there, and if I parse it and then get the data here, there are no data in the cape bytes section. So now let's get in how this works. We're just going to go ahead and switch over to a display capture because I cannot be bothered to set up more than that. So we're going to start out with our convert function here. This is a function that just runs other functions as well as removing data from the output array, because otherwise you just have extra data in there. That's not important. We're going to start out with our input here on interp bits. This, sorry, let me stretch, starts out by getting a value of the base64 number in the array. We're going to go to our get value function here. Now this is the only hard-coded section because I kind of have to hard-code this. This is the dividing line between this version and the more optimized version. And I'll get into that. I'll get to that here in a second whenever I talk about how I do the conversion. So basically, we are setting a value based on the character that is the current character in our string, our string array, which is a stupid thing to say. We're copying the 0 value into our temp value in our base64 in. So if I do data get base64 in, so data get storage base64 in, as you can see, we have our string array and then we have our temp value. Basically, we are copying, I didn't want to start up that program, whoops. We are just copying our string value at 0, which is our current value, to the temp value, and then based on what that value is, what character it is, it will write the corresponding base64 value. So A is 0, or capital A is 0, capital B is 1, etc. If we go down to lowercase a, it is 26, lowercase b is 27, and etc. all the way down to like plus and slash. And then we have our padding, which is equals, which I just have writing 64. I'll get into that in a second. Padding basically just writes as zeros because of how I do the bit writing. So after we get our value based, our corresponding value based on the character we're using, we then go to our bit convert, which is a complicated set of functions. We start out by writing some stuff to scoreboards, and then we are doing a binary conversion. We're taking that char value and we are converting it to a set of 6 bits because that is how base64 is stored, a set of 6 bits. Don't ask me to do this, to explain this. I'm terrible at explaining the math behind this. I just did it. Basically, to get binary, we're going to look at our start function here. This takes 2 values here. We're taking the add value and making it equal the value that we got in get value here, and then add, and then we're making this also equal that number, and then we're dividing this number here by 2 and then multiplying it by 2. This basically makes it so we get the remainder, because that's how you get binary, is you look at the remainder. And then we are taking our get bit 5 here after our start function. Get bit 5 just makes add equal our bit 5. So that's currently whatever the first number is, and then we are subtracting it to what our hold value is. And our start here, our hold value is divided by 2, then multiplied by 2. So if there's a remainder, our bit 5 will equal 1. If there is no remainder, it'll equal 0. And we just do that 6 times. The only difference here between these two is the number. If you look in our bit convert here, we have convert/next. Next basically does the same thing that the start function did here. It's just a little bit different. Instead of copying a number here, we're just dividing by 2 to start with. This is just so we can work on to our next number. And then we just do this 6 times, basically. And once we're done with that, we have a set of numbers in the scoreboard. Bit 0, 1, 2, 3, 4, and 5 are their corresponding bits for the base64 number. That's the best explanation I will ever do for this system, so please appreciate it. I am recording, thank God. Next, we are writing the bits to an array. So let's go down here, we'll go to write bits. Now this, we are writing the bit values in order from left to right, starting at 0 to 5, and we are putting these into an array called bits. in base64 main. This is the middleman between base64 to byte conversion. Basically, I probably could have done this better or differently, but basically I'm extrapolating the base64 value out to bits and then taking those bits and compressing them to bytes. And we'll get to that here in a second. This is how I write the bits. I store the value that it is in the scoreboard. As you can see right here, I execute store results storage into base64 main's temp value as a byte. I then run scoreboard players get bit 0 in and then after that I just append that value into our bits array from that temp value, and I do that 6 times. Now this right here is where these two versions would differ. I would basically remove these 2 steps in the thing, or in the function here, to optimize this. For get value, instead of doing a scoreboard set here, I would have a function that is just labeled by the number. And then for the actual function, I would do something like data modify storage base64 main bits append value 0b. I would basically do something like this. Let's say we're writing the value 27, right? Let me my example's 0 1 1 0 1 1. I would basically just do this as a function that would just directly go off of here. This would dramatically reduce the amount of commands I'm running, because I don't have to run the about 70 commands to do the bit conversion and then writing it to the array. Instead of 12 plus 70, so 82 commands per character being written, I would just do 6. So it's a lot more efficient, but also it's a lot more work at the beginning. It's basically the difference between doing your computation now and saving it, taking up storage space, or doing your computation later and using it computational power. It's sort of a computer science idea, splitting up where you're doing your processing. You could basically run Skyrim in a picture book if you know exactly what the player is going to do always, but that's a lot of processing power and chaos theory, so I'm not going to talk about this anymore. So that's where these 2 versions, that's where the more optimized version would diverge from this, but the rest has to go out the same exact way pretty much. So after we do all that, we just remove the next value, or the current value we're working on in that string array, and then we are just resetting our scoreboard, and then if we still have any values left in that string array, we loop this again. And once we're out of characters in our base64 string array, we then go on to our output, which is bits interp. Now for functions out, we have 4 functions. We're going to start by looking at bits interp. We can go ahead and close this. Yeah, we can close this. This also loops under the same condition, basically, just instead of being under that string array, it's our bits array, and it'll just loop this. We then have 2 functions here. We have read bits, and then we have write byte. So we'll read bits. This will convert the set of 8 bits into a byte. Now this does basic byte conversion, bit to byte conversion, which is additive. Basically, we are copying our position 0 into a temp value. That's with our next bit function here, actually. So that's what this does. Execute if data storage main bits. If there is something there, it'll run the function next bit. Now next bit writes the current bit value to the temp value in it. So if we do /data get storage base64 main, we have our bits and a temp value. All of them are pretty much the same. There's an array and then a temporary value. It will copy that to our temp value and then remove our current one. So basically it just shifts it into a temporary register. And then if that temp value is 1, we add 128. And then we do that again. Then we add 64 if it's 1. Then 32, 16, 8, 4, 2, and 1. Basically how that works is I'm just going to deal with the laggy Minecraft, because last time I did this I didn't tab, or I didn't, whatever, it doesn't matter. Basically, if you're you have your 7 bits in a byte, which is 0 through 7. If your 1, if your bit at position 0 is 1, you add 128. If your bit at position 1 is 1, you add 64. If it's at 2, you add 32, and so on. This is just the simple way to convert a bit to a byte, or really any binary number conversion. As you can see, that's what I do here. And then after that, we do a write byte. We're writing this to a scoreboard value. Our write byte function, whoops, I tabbed out of the wrong thing. Our write byte function then writes that scoreboard value to the temp value, and then we append it to an array in the base64 out bytes. So that's how the byte conversion. Wow, we're 4 minutes ahead of schedule. 4 minutes faster than what I did last time, and I explained more in this one. Not that it matters. That's how we just that's the basic base64 conversion. We extrapolate the base64 out to a list of bits, and then we compress that list of bits into a list of bytes. And those bytes correspond to ASCII characters and whatever else. I guess since I will explain how the cape thing works. So we're going to go ahead and move back to our data here and move to the interp. Let's go ahead and close all these functions because I don't need them open. If I go to functions, and then we go to parse here, this does an initialization, sets up the storage space. This also clears out any information. And then we are modifying from our base64 out value that we got. This is the list of bytes, and we're copying it into our cape check storage space into the same name list. And then we start a set of checks to look for a quote because of how these are set up. Basically, the base64 for a cape value outputs as a JSON array, I guess or a JSON object, compound, whatever. Let's go ahead and damn it, data get entity at s selected. We're just going to go ahead and copy this. Let me get my log open. So we need to go to .minecraft logs. And we're just going to go ahead and copy this base64 string. This is the base64 string that I'm converting in any given thing. So we will copy this, we will select all, run our base64 decoder. So basically what this is doing is we have a JSON compound, JSON thing, whatever, it doesn't matter what it's called. Basically what I do is I look for a quote in this. That's what I'm doing here whenever I say I'm looking for quote. Whenever it finds a quote, so we're going to do checks, look for quote. Whenever we find a quote, we're basically just doing array shifting. We're just scooting until we find, so data modify, we're putting the current position 0 byte into our temp value. Then if that matches 34, which is the ASCII character for a quote, we run check for cape. Now what we do then is we copy the first 6 bytes into our temp value, setting it as an array basically. then if it matches this, which is the text right here for this, we just, if we find that, we run initiate the cape copy. Now cape copy basically just deletes a bunch of data. If we found that cape text, I know for sure that I'm here in the thing, so I just delete all this. Then we just start copying data in our copy cape function here, and we just scroll through this until we find another quote, which I know for sure is going to be this quote right here, and then we have all this right here copied over into our cape bytes section, as you can see right here. And that's basically how that works. So that's that. I'm worse at explaining this system because it's more chaotic than the actual base64 conversion, because it's a little bit more botched together than the base64 conversion. But yeah, that's how this whole system works. I don't know if this is going to be a public video or if I'm just going to be sending this to a few specific people that asked for it or whatever. So yeah, thanks for watching, and I will catch y'all next time.